In the first question, we are taking a cross section perpendicular to the base. So if it was parallel to the base, it would have been answer choice for a hexagon, because if it was parallel to the base, it would have been the same as the base. I can't really draw, but it would have been the same as the base, which is a hexagon. But unfortunately, this question is perpendicular to the base, which means that we are cutting it vertically. So if you cut a prism vertically, it will be the same as the faces, which here are rectangular, so it will be a rectangle. For the next question, we are taking a rectangle that's 6 by 5, and we're rotating it around the longer side. We're going to see it on both sides. It's going to become circular. It's going to look like a cylinder. So that's between choices 3 and 4. And we can see that the radius is going to be 5 and the height is going to be 6. So that's answer choice number 3. For the fourth question, we have a pyramid with a square base. So I'm going to write down my volume of a pyramid formula, which is 1/3 capital B times H. Since it's a square base, the sides are the same. So I can think of it as length times width, or as side times side, since it's both the same. So I'm going to write that down, side times side, or side squared for short, times the height. It already tells us what the base area is. So the capital B is already 36. So I'm going to change this and edit this because they already tell me what the capital B is. Capital B is already 36. And they tell me what the height is. If I continue reading, the height is 10. So now I can multiply together and find the volume. So 36 times 10 is 360. And then times 1/3, which is the same as divide by 3, is 120. And then they're telling us that the density is 2.7 grams per cubic centimeter. The volume unit is centimeters, cubic centimeters, so we're good to go. That's what our volume's in. We don't have to do a conversion. Density is mass over volume. So the density that they give us is 2.7 grams per cubic centimeter. We are looking for the mass, and the volume is 120 centimeters cubed. I can see here the volume units are correct. They will cancel out, and I'll be left with my mass in grams, which is what the question is asking me for. I can put this over 1 and cross multiply. So that's 120 times 2.7. And that's 324. In this question, we need to find the volume of the cone. So volume of a cone is 1/3 capital B times H. And since a cone does have a circular base, the capital B would be the area of a circle, which is pi r squared, times the height from the original volume formula. So now I'm going to plug in what we know. The radius is 2.5. And we are actually not given the height. We're given the slant height. We need to find the actual height. We can do that using the Pythagorean theorem. 2.5 squared plus b squared equals to 6.5 squared. Make sure that you do plug in the 6.5 for c in the Pythagorean theorem, because that is the hypotenuse across from the 90-degree angle. 2.5 squared. That's 6.25. And now I need 6.5 squared. And that's 42.25. Okay, I'm going to subtract 6.25. And then the square root of 36 is 6. So we have that the height is 6. Now I'm going to plug the volume into my calculator, except I'm not going to put the pi in just because all of the answer choices have a pi in it. It's in terms of pi. I could put the whole thing into my calculator and then put all the answer choices into my calculator, but I'd rather just not put the pi into the calculator. So I'm going to type all the things here that are not the pi, so the 1/3, 2.5 squared, and 6. Parentheses are really important, especially when you're dealing with fractions or exponents. And we have 12.5. Make sure to write that pi next to it, because the pi was part of the volume formula, even though we didn't type it into the calculator. And that is answer choice number 1, 12.5 pi centimeters cubed. In this one, we know there's going to be a conversion because they give us a conversion factor, so that means we are going to have to convert. So we have a cylindrical pool, so the shape that we're dealing with is a cylinder. So I'm going to just write down my volume of a cylinder formula, which is capital B times H. And since a cylinder does have a circular base, capital B is the area of a circle, which is pi r squared. So we have pi r squared height. I'm going to leave that there for when we need it. The pool has a diameter of 16 feet, so that means the radius is half of that. The radius is 8 feet. And a height of 4 feet. So already, we're all in the same units, feet and feet. I can plug in to my volume formula. My radius is 8, and my height is 4. The pool is filled to a half foot below the top. Oh, so we're not filling the pool up all the way. So I'm not going to use the full height of 4, because I'm not filling the pool up all the way. I'm filling it half a foot below the top. So 4 minus half a foot would be 3.5 feet. So 3.5 feet is what I actually want to use for the height, because that's what's filled of the pool. How much water does the pool contain to the nearest gallon? So it's just asking how much water is in the pool. So how much can you put in it? That's volume. So all we're doing is finding the volume. But it does say the volume to the nearest gallon. Our 8 and our 3.5 are in feet. So when we find the volume, our volume is going to be in cubic feet. So we'll just have to convert it to gallons after that. So I'm just going to type into my calculator pi 8 squared 3.5. And that's about 703.717. And then it gives us the conversion to gallons. So for every cubic foot, there's 7.48 gallons. So you might see that we're going to multiply by 7.48. If you don't see that, or you have trouble seeing that, you can always make a proportion. The proportion would be as follows. If there are 7.48 gallons for every cubic foot, how many gallons are there for 703.717 cubic feet? And then we can cross multiply and we can see what we get. And we see that we're multiplying by 7.48. And that's approximately 5,263.8. And it does say to the nearest gallon, so we're going to round up. And that's 5,264 for the total volume. Which figures below can have a triangle as a cross-section? So a cone, absolutely, because if you take a vertical cross-section, it will be a cone. Just like there's a triangle part of the cone. If you take a vertical cross-section, it'll be a triangle. There's the triangular part of the cone, so that one should be a little bit obvious there. So one does work. A cylinder, you're not going to be able to get the triangle out of a cylinder. A cylinder, you could get circles if you go parallel to the base. You could get rectangles if you go perpendicular to the base. And you can get an ellipse if you go diagonally, but you're not going to be able to get a triangle out of it. a square pyramid, I think that should be another obvious one that we are going to be able to get the triangle out of it, because a pyramid does have triangular faces. So we are going to be able to get a triangle if we do a vertical cross section of any pyramid. It will be a triangle. The horizontal cross section will depend on what the base is, but the vertical cross section will always be a triangle. So the last one that it will be is a cube. A cube, if you cut diagonally slanted towards the top through a corner. I'm really bad at drawing, but just to show you with just a flat square, because a cube is made up of squares, you can get a triangular cross section if you slice diagonally. Hopefully you see that this looks like a triangle over here. So this one should have been an easy one with process of elimination though, because there was no answer choice that said only 1 and 4. So once you determine that 1 and 4 for sure are correct, then your other option is just to decide between cylinder and cube, and there's no way in a cylinder that you're going to be able to get a triangle. So the correct answer is 4, 1, 3, and 4. Here we have a triangular prism. For any prism, the volume is capital B times H. Since the base is a triangle, because it's a triangular prism, remember shapes are named for their bases. So the base is a triangle, so we're going to use the area of a triangle formula for the area of the base. So the area of a triangle is 1/2 base times height. And then we still have the height of the entire prism. So first, let's focus on the area of the triangular base, the 1/2 base times height for the triangle. So I'm going to put an arrow here for the triangle. So area of the triangle, so 1/2. The base of the triangle is 6, and the height of the triangle is 4. So that is half of 24, which is 12 inches, times the height of the entire prism. And the height of the entire prism is 10. So we have 120 cubic inches. And it does say to find the volume in cubic inches. So that's our answer. We're dealing with a golf ball, which is a sphere. So our volume of a sphere formula is 4/3 pi r cubed. And it tells us that the diameter is 1.680 inches. So I'm going to just divide that by 2 to get the radius. And the radius is 0.84. And then I'm going to continue reading. So if I would find the volume right now, that would be in cubic inches. So I'm going to keep reading and see if a conversion is necessary or anything like that. The material used to make the golf ball weighs 0.6523 ounce per cubic inch. There's 2 units here. So one's a mass unit and one's a volume unit. And that means this number is the density. And the volume unit is cubic inches. So it looks like I'm good to go finding my volume in cubic inches. And then what we're actually finding is the mass of one golf ball. So now we can continue finding the volume and plugging into the density formula. So I have 4/3 pi. The radius was 0.84 to the 3rd power. And that's approximately 2.4827. So that is the volume of one golf ball. So now I'm going to go over to my density formula. Density is mass over volume. The density is given to us as 0.6523 ounces per cubic inches. We are looking for the mass. And the volume is 2.4827 cubic inches. So our volume units are good. They cancel out. And that means that we're going to be left with the mass in ounces, which is what the question's asking for. So good to go. We can cross multiply. M is equal to, let's multiply these together. So I'm going to multiply by 0.6523. And that's approximately 1.619. And that to the nearest hundredth is approximately 1.62. Okay, for this one over here, we have a prism that has a cylindrical hole, and we need to find the volume of the solid without the hole. So we're going to find the volume of the whole prism, the volume of the cylinder, and then subtract the two. So volume of any prism is capital B times H. So I'm finding the whole prism. And since it's a rectangular prism, the area of a rectangle is length times width. So length times width times height is our volume formula. So that would be 4 times 4 times 6. And I can just type that right into my calculator. And that is 96 cubic inches. And now we can find the volume of the cylinder. Volume of a cylinder is capital B times H. And since a cylinder has a circular base, the area of a circle is pi r squared. So pi r squared height is what we're going to be using. And the radius of the cylinder is given to us as 1 in the question. And since it's drilled through the entire length of the box, the height is the same as the prism, which is 6. So volume is 6 pi. So now I'm going to subtract the 2 in my calculator. And sorry, this is also in cubic inches. Everything was in inches. So 96 minus 6 pi. And it says to round to the nearest tenth. So that's approximately 77.2 cubic inches. The next question is asking you to use Cavalieri's principle to explain why the two solids have equal volumes. So Cavalieri's principle is a two-part principle. I'm going to write it down over here. Cavalieri's principle. So I'm just going to write down what it states. It states that if two solids have equal heights and have equal, let me write that differently, areas of cross sections, then the two figures will have the same volume. So you did have to state to get full credit that these two figures have the same heights and that they have the same areas of the cross section, but you also have to use the information from